5.4 goes over solving special systems of linear equations. You have 3 different types of solutions when you're working with systems of equations. One is one solution, the second is no solution, and the third is infinitely many solutions. So what you've seen prior to today is where those 2 lines cross, you have that one solution. Today you're going to be looking at some that have no solution and some that have infinitely many solutions. When you have 2 lines that are parallel to one another and they never intersect, you have no solution. If you have 2 lines that are exactly the same line, so they overlap at all points, you have infinitely many solutions. If we look at example 1a, we're solving the system of linear equations any way you want. So we could graph these, we could use substitution, we could elimination. It's totally up to you. I'm going to use substitution here because I have a y is equal to and a y is equal to. So we have y is equal to 2x plus 1, y is equal to 2x minus 5. I'm going to set this equation or this expression equal to this expression. So we have 2x plus 1 is equal to 2x minus 5. When we subtract that 2x from each side, we're going to be left with 1 is equal to negative 5. This is not a true statement, and there is no way possible that 1 can equal negative 5, so this one is just no solution. For example B, we have y is equal to negative x plus 3, and 2x plus 2y is equal to 4. For this one, again, I'm going to use substitution because I have a y is equal to. So if y is equal to negative x plus 3, I can just plug in that negative x plus 3 for y in my second equation. So this is going to give me 2x plus 2 times whatever y was equal to, so that's that negative x plus 3 is equal to 4. I'm going to start this one by distributing that 2 into the set of parentheses, so it gives us 2x minus 2x plus 6 is equal to 4. From here, we're going to combine those like terms of that 2x minus 2x, which cancels out, and we're just left with 6 is equal to 4. Once again, this is not a true statement, so we have no solution. If we look at example C, we have y is equal to negative 10x plus 2, and 10x plus y is equal to 10. Once again, we have a y is equal to in this situation, so I'm going to take that negative 10x plus 2 and plug it in for y. This is going to give me 10x minus 10x plus 2 is equal to 10. Those 10x's are going to cancel each other out, so we just have 2 is equal to 10. This is not a true statement, so once again, we have no solution. The next part of our lesson, we're going to be looking at solutions that have infinitely many solutions. So this is when you get true statements for these. If we look at example A, we have negative 2x plus y is equal to 3. And negative 4x plus 2y is equal to 6. With this equation or these equations, I don't have anything that are opposite signs, so my x's don't have opposite signs, nor do my y's. So I'm going to choose to solve for y in that first equation because I do have a y with a coefficient of that invisible 1. So I'm going to take that negative 2x plus y is equal to 3 and move that 2x over by adding it to both sides. So I'm left with y is equal to 2x plus 3. I'm going to take this 2x plus 3 and I'm going to plug it in for y in that other equation that I have and solve for x. So I'm going to have negative 4x plus 2 times 2x plus 3 is equal to 6. From here, we can distribute that 2 to get negative 4x plus 4x plus 6 is equal to 6. The negative 4x plus 4x cancels out, so we have 6 is equal to 6. That is a true statement, so this is infinitely many solutions. For B, we have x plus y is equal to 3, and 2x plus 2y is equal to 6. Now with this top equation, I'm going to choose to multiply this top equation by a negative 2, so that way I can cancel things out here. So I'm going to have negative 2x minus 2y is equal to negative 6, as well as a positive 2x plus 2y is equal to 6. So again, with these, I'm going to combine them by adding them. So those 2x's cancel, the 2y's cancel. I have 0 is equal to the negative 6 plus 6 is 0. 0 is equal to 0. Is this a true statement? Yes. So I have infinitely many solutions. For example C, we have 3x minus 2y is equal to 8, and 6x minus 4y is equal to 6. I'm going to choose to eliminate for this one and multiply that top equation by negative 2. This is going to give me a negative 6x plus 4y is equal to negative 16, as well as the one that I have on the bottom already, that 6x minus 4y is equal to positive 16. I'm going to combine these two equations by adding them. So my 6x's cancel out, my 4y's cancels out. We have 0 is equal to the negative 16 plus 16 is also 0. So I have a true statement. This is infinitely many solutions.